Hi everyone, I'm here with your 814 lesson, How Can I Display Variability? Box plots and interquartile range. Get your facts first and then you can distort them as much as you please. This is a quote from Mark Twain, a famous American writer and humorist, 1835 to 1910. He also said, facts are stubborn, but statistics are more pliable. What do you think he meant? Much of what you learn and interpret about different sets of data is based on how it is presented. In this lesson, you will use several mathematical tools to look at data in different ways. As you work, use these questions to help focus your discussions with your team. What can we conclude based on the representation? What cannot be concluded based on the representation? And how are the representations related? So looking at 846 to start. Starts down at the bottom here. The histograms your class made in problem 844 display data along the horizontal axis. Another way to display the data is to form a box plot which divides the data into 4 equal parts or quartiles. To create a box plot, follow the steps below with your class or in your team. So I did not have you make the box plots or the histograms, but I have already made them. They look like this. So if you need to refer back to them, you can do that. But we are going to work on making a box plot. So it says, with a sticky dot provided by your teacher, plot 1975 temperature for your city on a number line in front of the class. So if you're not in class and we can't do this, so what you need to do then is you need to make a number line. Like so. I go from all the way to 10 degrees, all the way up to 80, over 80, basically to 90. I counted by 2, so each line is 2. I then, on my resource page, plotted the temperatures for 1975, which is this first column right here. Okay. So as you could see, the first temperature was 13 degrees. So on my number line, 13 degrees is all the way over here. So you will need to do the same to make sure that you have all of your data accounted for. So what is the median temperature for 1975? Place a vertical line segment about 1/2 inch long, marking the position above the number line on your resource page. So remember, median means middle number. So what you should do is you should list all of these temperatures in order from least to greatest, starting with 13, 29, 52, and I have these numbers from my number line. So that is the numbers and the temperatures in order from least to greatest. So now we just start crossing out. I missed one somewhere. 13, 29, 52. Oh, I forgot 74. That was my fault. I went a little out of order, I'm sorry. But your median should be 63 degrees. So now on your resource page, you need to go down to 63 at the bottom and put a line about a ½ inch long. So 61, 62, 63. Looks like that. C says, how far does the data extend from the median? That is, what are the minimum and maximum temperatures in 1975? Place vertical line segments marking those positions above the number line. So you can see from above that the minimum is 13 degrees Fahrenheit and the maximum is 84 degrees Fahrenheit. Okay, 84 is right here. So now we're going back here, putting a line, ½ inch line at 13, putting a ½ inch line at 84. So far we have 3 ½ inch lines. D says, the median splits the data into 2 sets, those that come before it and those that come after it when the data is ordered from least to greatest, like it is on the number line. Find the median of the lower set, called the first quartile. Mark the first quartile with a vertical line segment above the number line. So the first quartile is 13 all the way up to 62. It's everything before the median. So we're going to rewrite it. And we need to find the median again. So lowest, highest, lowest, highest. And I'll try not to mess up this time. So here, it's 56 degrees Fahrenheit. So we go back to our chart and we put a vertical line at 56. Finally, the last part says, look at the temperatures that come after the median on your number line. The median of this portion of data is called the third quartile. Mark the third quartile with a vertical line segment above the number line. So now we're doing, back here, we're doing everything after the median, so 66 to 84. So I'm going to rewrite those. And again, find the median. Lowest, highest, lowest, highest. Continue following that pattern until you have one left, and it's 73 degrees Fahrenheit. So I'm going to go back to my resource page now and mark a line at 73 degrees. F says, draw a box plot that contains all of the data points between the first and third quartiles. Your graph should be similar to a box with outer segments like the one shown below. So now I'm going to turn it so I can connect it. But we are connecting our box like so. And then there's just a line out to the minimum and a line out to the maximum. So your box plot, once connected, should look something like this. Okay, 847 wants you to do the same thing that we just did, but with the temperatures for 2000. So you will be completing that for 2000, and that's going to be something that you are going to try on your own. One final thing I want to talk about is 848. So in 848, we are introduced to interquartile range. So at the beginning, it says, by looking at your box plots on problems 846 and 847, determine the year the temperature had the greatest range. So remember, range is your maximum minus your minimum. So I'm just going to do 1975. And your responsibility is going to be to do year 2000. So 84 minus 13 gives you 71. So your range is 71. your job is going to be to do 2,000. B says, in addition to range and mean absolute deviation, there is another way to calculate spread. The interquartile range, IQR, is found by calculating the difference between the third quartile and the first quartile. It is the range of the middle 50% of the data. Calculate the interquartile range for the temperature from data 1975. So we know that our upper quartile or our third quartile is 73 degrees, and we know our first quartile is 56 degrees. So 73 minus 56 is 17 degrees. So your IQR for 1975 is 17. Your job is to answer part C. Calculate the interquartile range for the temperature data from 2000. We have gone over one of each of these together, and it'll be your responsibility to finish it. If you have any questions, please let me know.